Welcome back, everybody, to our final video in this series on the Math CAASPP Grade 7 Math Practice Test for CAASPP. And in our last video, we ended on number 27, and I was a little bit unsure on the answer if they would be looking for 42 wheelbarrows or 41 wheelbarrows, because it came out just a hair over 41. And I said we should go with 42. But I said I'd go back and check the answer key, and I did. And they actually do have 42 wheelbarrows. So something to keep in mind, you don't always round down. You have to read the context of this problem. And in this case, rounding up was what you needed to do. All right, so here we go. Question 28 as we work our way to question 32 and finishing the test. It says this graph shows a proportional relationship between the number of gallons of gasoline used, G, and the total cost of gasoline, C. Find the constant of proportionality, R, using the value for R and an equation in the form C equals RG that represents the relationship between the number of gallons used, G, and the total cost, C. All right, so if you've been watching these videos and working through these problems, then you should remember, if you didn't remember already, about the constant of proportionality. So in a proportional relationship, the constant of proportionality, we usually use the letter K, is equal to, well, I'm just going to go ahead and write that what it is. K is equal to the constant of proportionality and the constant of proportionality is equal to K is equal to Y divided by X, or the output variable divided by the input variable. And the equation of a proportional relationship can be written as Y equals KX, or the output is equal to the input times K. The output is equal to the input times K. Now, in this situation, they messed everything up by using different letters. So we're going to have to think through it a little bit. Here we go. So first of all, they want to make the constant proportionality R. So where we have K, they are using R. All right? So Y is equal to, this would be R right here, okay? All right, Y, this is the Y-axis, so the variable they're using for Y is C, right? So this is my Y-axis, and this is my X-axis. So where we see Y, it's actually equal to C, and where we see X, it's actually equal to G, right? So Y, the cost, is equal to R times G, where G is the gallons used and C is the cost. So if we want to know what that constant of proportionality is, right? Because that's what they said find R using the value for R, right? The equation. So actually what we want is the equation. And in order to write this equation, we need to find out what R is, which means we need to go back up here. R is equal to C divided by G. All right, now let's go back to the graph. Looking at this graph, I could know without them telling us that this was a proportional relationship, because what do we have? We have a straight line. We have a linear relationship that goes through the origin, and that shows a proportional relationship on a graph. Now, this line is made up of a bunch of points, and these points make this proportional relationship true. So for any of these points, if I take C divided by G, it will give me R. Now, as I'm moving along this line, I'm not sure what the values are for C and G here, but when I get right here, it looks like I found a point that's both on the line and on the grid. On the line and on the grid. And remember, the X value comes first, so the X in this case is G. The number of gallons used right here is 3, right? It goes up from 3. and then it goes over to what? To 10. So 310 is a point on this line. Now, if you want to know if you've got a correct point, if you do the same thing again, if I go over 3 over and then up 10 more, am I on the line again? I actually am. 6, not 610, excuse me. It's 6 what? 620 is also on the line. So is 930. And this last point right here would be 1240, right? So any of these points, I have the number of gallons used and then the total cost, G comma C. And if I want to know what R is, it's C divided by G. So I could do 40 divided by 12, or I could do 30 divided by 9, or I could do 20 divided by 6, or I could do 10 divided by 3. All of those will give me the value of R. Now, if I were to go to my calculator, and they let us use a calculator on this problem, you could see, actually, I've already got here 10 divided by 3, and I get 3.333333, right? So if I do it instead, if I do 20 divided by 6, 20 divided by 6, I get the same answer. Do you believe me if I change this to 30 divided by 9? And finally, 40 divided by 12? All of them give me the same thing every time, which is 3.333333, which would be 3 1/3 as a mixed number. So if I had a way to put that in as my answer, I could put 3 1/3. I don't want to put it as a decimal, because if I put 3.3, then I've rounded. If I could put that would be a way to do it, but I don't think I can do that. I don't want to do that. So 3 1/3, or how about we just put 10/3, right? 10/3 will give us the exact answer in that form. So this also is exact. All right, that would be exact if we could put it. So, but let's just go ahead and put the answer as 10/3. So the value of R is 10/3. I'm going to click on the fraction here, and I'm going to put 10 for the numerator, and I'm going to put 3 for the denominator. And that is the value of R, the constant of proportionality. All right, that's 28. Let's go on to number 29. Here we go. When playing basketball, Jan makes 4 out of every 10 shots she takes. So Jan makes 4 out of 10. All right, so before I actually read through what they're asking, I like to just do some math with what they gave me, because oftentimes by doing that, I'll have the answer. So if I were to write it, that ratio as a fraction, 4 out of 10, I know that 4 out of 10 can simplify to 2 out of 5. So maybe one of the questions below will ask if there's a relationship here, 4 out of 10 equals 2 out of 5. All right, I also know that I can make that a percent. Don't know if I'm going to need it, but 4 out of 10 is 40%. I also know as a decimal, it is 0.4. And if Jan makes 4 out of 10, I have a question for you. How about how many she misses? If she makes 4 out of 10, she misses 6 out of 10, right? And if she misses, this, by the way, is makes. Let's go ahead and go over here for misses. She misses 6 out of 10, which means she misses what? 3 out of 5. She makes 40%. She misses 60%. She makes 0.4. She misses 0.6. All right. So again, I did that without even reading through the questions, just because it gives me a basis of going forwards. All right, so here we go. Question number 1. It says select all that describe Jan's situation. Again, when you see these squares, All right, they shouldn't have to tell you to select all. That lets you know that there is probably more than one correct answer. I haven't come across a single one of these yet where there was not more than one correct answer when they said select all. All right, here we go. The ratio of the number of shots Jan makes to the number she takes is 2 out of 5. So makes to takes, right? Makes is 4, takes is 10, but we already said that that simplifies to 2 out of 5, so yes, sirree, Bob, that one is correct. The ratio of the number of shots Jan makes to the number she does not make is 2 to 3. So misses, do you agree, is not makes? All right, so she makes 4, she misses 6, right? So makes 4, misses 6, 4 to 6. What does that simplify to? When you divide both of those by 2, you get 2 to 3. That one is also correct. The equation 4x equals 10y shows the relationship x, the number of shots Jan makes, and y, the number that she takes. All right, so this one looks confusing, all right? But let's look at it a little closer. What does it say that x is? The number of shots she makes. And what does it say that y is? The number of shots she takes. Well, let's look at that equation and let's pick a value for x and y and see if it makes it true. Well, what do we know? We know that when she makes 4, she misses what? 6. X is the number she makes. Oh, wait, that's takes. Excuse me. Takes. She makes 4. She takes 10. My bad. All right. So I just have a question for you. Does 4 times 4 equal 10 times 10? Does 16 equal 100? And the answer is no. 16 does not equal 100. So this one is no. So this looked really scary, but if you just plug in a value for x and plug in a value for y, it doesn't make it true. All right, let's do this next one then. 6x and 4z. Now, x is still the number of shots she makes, which we said we can use 4 for. But now z is the number of shots she doesn't make. That's the one I went to use initially, and that's 6. What's 6 times 4? 24. What's 4 times 6? 24. Is that true? Yes. All right. So there we go. We're looking for the first, the second, and the third choices make it true. Sorry, the first, the second, and the fourth, not the third. Awesome. All right. Onward, forward, question number 30. Mary and Jerry are exercising on a track. Mary is walking at a rate of 3 miles per hour. Jerry starts jogging at a rate of 4 miles per hour after Mary has been walking 15 minutes. Jerry jogs 2 miles as Mary continues walking, and they both stop at the same time. Enter the total distance that Mary walks around the track. All right, so ladies and gentlemen, hopefully you know by now the relationship that says distance is equal to rate times time. Distance is equal to rate times time. All right, so we've got 2 people walking here. We have Mary, and then we have Jerry. All right, and what does it say? Mary is walking at a rate of 3 miles per hour. That is her rate, 3 miles per hour. Jerry actually is not walking. He's jogging at a rate of 4 miles per hour. That is his rate. All right, so we now have the rate part of this equation taken care of. But what about the time? Does it tell us how far, it's not far, excuse me, how long each of them were going? All right, well, it says Jerry started 15 minutes after Mary, right? And then it says Jerry jogs 2 miles as Mary continues walking, and they both stop at the same time. So darn, they told us how long Jerry waited after Mary started, and they told us that they stopped at the same time, but they didn't tell us how long either one of them went. Can we figure it out? Well, we don't know either of their times, but what about distance? What about distance? Do we know how far Jerry went? Well, Jerry jogs 2 miles. So Jerry's distance, we know, is what? 2 miles. We just said we don't know Jerry's time, but what do we know? We know Jerry's what? Jerry's rate is 4 miles per hour. So distance equals rate times time, but what does time equal? If I want to know the time, then I can take the distance divided by the rate. How far you go divided by how fast you're going will tell you how long it took you to go there. So what was Jerry's distance? Jerry's distance was 2 miles. And what is Jerry's rate? 4 miles per hour. So 2 miles at 4 miles per hour, how long does it take him? Well, 2 divided by 4 is what? 2 divided by 4 is 1/2. So it takes him 1/2 of an hour. So we know that Jerry's distance was 2 miles. We know his rate was 4 miles per hour, and we know his time was 1/2 an hour. All right? But what did it ask us for? It asked us for Mary's distance. Well, Mary's distance is going to be her rate times her time, right? Her rate times her time will be her distance. But what was her time? Jerry starts jogging after Mary has been walking for 15 minutes. So Mary walks 15 minutes, right? Then Jerry joins her. How long does Jerry go for? 1/2 an hour, right? 15 minutes plus 1/2 an hour more. So what was Mary's total time? 15 minutes plus 1/2 an hour. Well, 1/2 an hour is what? 30 minutes. So she went 45 minutes. But her rate is 3 miles per what? Hour. So we need to change 45 minutes to what part of an hour? All right, so I know that we don't use traditional clocks nearly as much as we used to. But when you work your way all the way around a traditional clock, you go 1 hour, right? And 1 hour is 60 minutes. And every one of these is 1/4 of an hour, right? 15 minutes. 15 minutes is 1/4 of an hour. 30 minutes, right? That's going to be 1/2 an hour. And 45 minutes, that's going to be 3/4 of an hour. So 45 minutes is 3/4 of an hour. So Mary's distance, that's what they're asking us for. Mary's distance again is equal to her rate. So if we're looking at Mary here, D equals her rate. What was her rate? 3 miles per hour times 3/4 of an hour. So we have 3, or 3/1, times 3/4. And what do we get? We get 9/4. 9/4 what? 9/4 miles. Because she goes 3 miles per hour. Distance is equal to rate times time. 3 miles per hour times 3/4 of an hour is 9/4 miles. All right? So it says enter the distance in miles. So we could put 9/4, except I'm looking and I'm not seeing any fraction option. So 9/4, how many times does 4 go into 9? 4 goes into 9 2 times. So it would be 2 1/4 miles. But again, I don't see a fraction here. So 2 1/4 miles. Do you know what 1/4 is as a decimal? 1/4 is 0.25. That's one of those ones you should have memorized. 2.25 miles, which should make sense because if she had gone a full hour would be 3 miles, right? She didn't go a full hour, so she had to go less than 3 miles. She went 2.25 miles. 2.25 miles. All right, that's her total distance that she went. All right, here we go. Next question, 2 to go. Marcus has a pool that can hold a maximum of 4,500 gallons of water. The pool already contains 1,500 gallons of water. Marcus begins to add more water at a rate of 30 gallons per minute. Write an inequality that shows the number of minutes M Marcus can continue to add water to the pool without exceeding the maximum number of gallons. All right, so this is a great follow-up after the problem we just did. We just did a problem that said distance is equal to rate times time, right? Distance was rate times time. Well, now instead of distance, we have volume. The volume is equal to the rate times the time. So it's a very similar relationship, except instead of going a distance, we're filling up, okay? So volume in this case is going to be the gallons of water. What's the rate? The rate they told us is what? 30 gallons per minute. And what's the time? Well, that's what we're asking. All right. The time is going to be the number of minutes. Minutes. How about that? That's better, huh? Number of minutes. Okay, so, and notice it says enter an inequality. Just a reminder, okay, if we're writing an equation, it will have an equal sign. If we use one of these, that's going to be an inequality, right? So this one means is less than, right? This one means is less than what? Or equal to? Didn't leave myself enough space here. This one right here means is greater than. And finally, this last one is greater than or equal to, right? Okay, now they don't want us to exceed the maximum? So let me ask you a question. We're filling up the pool and we don't want to exceed it. Well, we can't use this one, right? We can't use that because that would make it an equation. So it's got to be one of these, all right? But we don't want to exceed the maximum. So which of these would allow us to exceed the maximum? Well, if we're greater than, then that's above the maximum, right? If we're greater than or equal to, the equal to part would be okay, but not the greater than. All right, so it's not going to be one of these greater thans. So it's either is less than or equal to, right? Well, it says without exceeding the maximum. If you reach the maximum, have you exceeded the maximum? The answer is no. So we can be less than, or we can be less than or equal to. So this is what we want right here. So we're looking for less than or equal to. So when we go to pick our answer, that's the one we're going to want. So instead of volume is equal to rate times time, we're going to have volume, right? The volume, we want to be less than or equal to that volume. And I'm switching this around. I realize actually now that I went through all that, we want to be less than or equal to the maximum volume. And how do we get that? It's rate times time. If we went the other way, like I had written it, then we would want the volume to be greater than or equal to the rate times the time. So for the way I wrote it initially, actually the volume needs to be, the rate times the time needs to be less than or equal to the volume, right? If the volume is greater than or equal to the rate times the time, that means, right, that this is less. This is our water, and this is the volume of the pool, right? So we want the rate times the time to be less than or equal to the maximum volume. Okay, so it says the pool can hold 4,500 gallons of water, right? So we might be tempted to put 4,500 gallons here, except what? We've already got 1,500. So it already has 1,500. So what do we need to do? We need to take that 1,500 away and get what? 3,000. So when we multiply the rate times the time, we want it to be less than or equal to 3,000. Because if it goes above that 3,000, the water is going to overflow. All right, do we know either the rate or the time? And the answer is yes. What is the rate? We know that the rate is what? 30 gallons per minute. What is it that we don't know? We don't know the time. So right here is an inequality that we can put 30 times t, or in algebra, we usually just put the coefficient right in front of it. 30 times t has to be less than or equal to 3,000. If we had done it this other way over here, 3,000 would have to be greater than or equal to 30 times t. That also would be correct. All right, but I'm going to go ahead and put it here. So 30 times the time, except remember our time is not t, it's m. So 30 times the number of minutes, what did we say, is going to be less than or equal to 3,000. And if we solved that, we would find the number of minutes. And if you divided both of these by 30, you would see that it would be 100 minutes. If we went less than or equal to 100 minutes, we'd be good. If we went even a second over 100 minutes, that pool is going to overflow. All right, boys and girls, we are on our last question. Number 32, are you as excited as I am? I hope so. Here we go. Values for A, B, and C are graphed on the number line shown. Use the graph to evaluate the expressions on the table. Select one column for each row in the table and indicate whether the expression is less than 0, equal to 0, or greater than 0. Wow, you know, it'd make this a lot easier if they gave us numbers. All right, Now they didn't give us any numbers, but let's talk here. We have 0, right? And everything to the right of 0 is going to be what kind of number? It's going to be positive. And everything over here to the left of 0 is going to be what? Negative. Now, if you're going, well, can't I just put numbers on here? Can't I say this is 1 and this is 2 and this is 3 and this is 4? Well, it might be 1, 2, 3, and 4. It might be 2, 4, 6, and 8. We don't know, but let's just go ahead and pretend for a minute that those were the values. So again, we don't have a scale. These might not be the values, but we do know some things here. If that number is 2, that number has to be -2 because they are what? They're the same distance away. So these two numbers have the same absolute value. So if that weren't 2, say it were 4, then that one would be -4. And let's think about it. If we were to do A plus B, and let's just say A is -2 and B is +2, what do you notice? We get 0, right? Excuse me. If it did happen to be -4 and +4, we would also get 0. So the fact that these have the same absolute value means that when we add them, we will always get 0. They are opposites, right? And we also know something else. We know that C is greater than B. C is bigger than B. So if I subtract C minus B, like if I did 4 minus 2, what kind of number do I get? I get a positive answer, right? Again, if I did 8 minus 4, what kind of answer do I get? I get a positive answer. So again, we don't know for sure those are 2 and 4, but if they are, guess what? We're going to get the same result as if we did, at least in terms of equal to 0 or greater than 0. What about if I do B minus C? What's 2 minus 4? That's a -2. What about 4 minus 8? That's a -4. A smaller number minus a bigger number will always be a negative. So I hope you get what I'm saying here. We don't know that these are the actual numbers on the scale, but we can go ahead and use these ones because when it comes to absolute values and opposites, these distances are going to hold. And all we're asked is it going to be less than 0, equal to 0, or greater than 0? All right, let's take a look. Here we go. A minus B. A minus B. So let's just use these numbers. A minus B is going to be -2 minus 2. -2 minus 2 is what? -4. And -4 is less than 0, right? Just think about this. We're at a negative and we're taking away a positive. We would actually be going back that way, and that's less than 0. All right, A plus B. We actually already did this one, didn't we? A plus B, -2 plus 2, that actually equals 0. Because those are opposites, it's exactly 0. All right, B minus C. We actually did this one as well. B minus C, in this case, 2 minus 4. When a smaller number takes away a bigger number, you're going to get a negative answer. So that one is less than 0. C minus A. C minus A. 4 minus a -2. Well, subtracting a negative is the same as adding a positive, right? A positive, take away a negative, you're always going to end up adding. So that one is greater than 0. That would be moving us this way on the number line. Subtracting a negative moves you to the right. Subtracting a positive moves you to the left. And finally, A plus C. All right, so our last one, A plus C. A we've labeled as -2. C we've labeled as 4. And we end up with +2. Because when we add these, which has the greater absolute value? C has a greater absolute value, so when you add, you will always get the sign of the one with the greater absolute value. So this one is greater than 0. All right, so again, just to reiterate, we didn't know that these were the exact values here, but we didn't really have to. We just had to know positive versus negative and distance relative to the other ones, okay? So we've got less, equal, less, greater, greater. Less, equal, less, greater, greater. And ladies and gentlemen, I believe that we have reached the end of the test. Well, thank you so much for watching all these videos. I hope you learned a lot. Make sure that you are taking these skill quizzes, and then I encourage you to go back and retake the practice test all over again. Have a good day, everybody. Bye.